Yes. So you're going to take the paper, you're going to divide it as we discussed. You're going to record over here your notes. And you're going to have a whole notebook of these kind of keywords, ideas, questions, right? Everybody got that? Where you here's where you're reducing what you saw here you recorded here, whether it's a graph or it's whatever, you're reducing it here for the keywords, main ideas, questions, statements, a quiz on Friday, and then you might want to highlight it, and so you make sure you do that. Again, this part is not done in class. This part's done after class. Study hall. I see kids in my study hall that I have in class, and they're laying their heads down, and I'm wondering, why are you not going over your notes? Every day you should go over your notes. You should be figuring out what's important, what's going to be on the quiz, when is the quiz, let me plan out my study time, make index cards on the main ideas. Like, there's a ton of stuff you can do that's not assigned to you. That's what being a student, part of the job of high school is to get you to become an independent learner. Independent learner. A learner that's not dependent on the teacher. A learner that does things that they need to do on their own. They self-control, they self-regulate their behavior, they make their own study cards, they find their own sources, and they figure things out. And they use the teacher less and less as they move forward in their education. By the time you get to be an MD or PhD, you just need the teacher to give you information. You'll take care of the rest. And eventually, you'll be teaching. That's the whole point. So here, we're going to put the summary, and that's every day, right? Every day you're putting a summary, you're putting question, keywords, Friday, main ideas, and record the information. You're going to put this in a 3-ring binder. And everything, the 3-ring binder is going to have your name on every page, your date, name, page, name, date, name, date, name, date. Again, every page is going to be divided, and you're going to have, now you could, as I suggested to you earlier, there is another way you can do it if you'd rather, because you want more space. You could go ahead and do your 3-ring binder and have this as your main ideas, and then this side as your record of that date, and the summary can even be over here as well. Whatever the idea, the point is that whichever way you decide to do it, you have a binder that's just full of these dates, one note per day that we have class. Even if I'm absent, what did you do that day? You did something, a paragraph that says, Mendoza was absent, I worked on this, you have an assignment if I'm absent, so there's a note for every day, 1 page at least, and you have the main ideas. If I leave you some work, some main ideas, some questions, and a summary of what you did. Then before every assessment, like this Friday, you have a test, a quiz. It's a 20-minute quiz. It's going to cover all the ideas in that green sheet. Well, Thursday after class, oh, that's not right. Thursday night, when you leave class, we would have done practice, we would have done reviews. All that's over here in your Cornell notes. On this side is a green sheet. Your sheet's going to be green. Is a green sheet that summarizes the concepts as you see in front of you. Every quiz, every test will have a summary. And look at the last page. What do you see on the last page of that green document? What is on the last page of that green document? It's a checklist. It's a checklist of what's going to be on the exam. What's going to be on that assessment. It's your assessment checklist. If it's a quiz, it'll be a short list like the one you see in front of you. If it's a test, it'll be a longer list. So let's read this. The what is it? 9 things that are going to be on the test. 9 ideas that are going to be on the test. What are the 9 things that are going to be on that test? Somebody want to tell me? Tell me one. Ladies, what's one thing that's going to be on that quiz on Friday? One thing that's going to be on the quiz on Friday. The steps of the scientific method. Which are what? What are the steps of the scientific method? We talked about it this week, the last couple of weeks, right? What is it? What are the steps of the scientific method? Observation. Ask a question. Research. Not yet. After the question, after research, after the question, yeah. Construct a hypothesis. Excellent. Can we put those tools down? And what? Sorry. Experiment. So we do an hypothesis. We write an experiment. We observe and record our data, or whatever you want to say. Analyze our data, right? And then we finally come up with a conclusion. I wrote out the summary of the steps there for you. Did you see that? The details are in your notes. The details are in the YouTube videos that are posted on the class YouTube channel. The details are in the notes we covered in the practice activities that we've done. And the case study, the Arctic ice melting case study, those details are all in all that work we've been doing over the 2 weeks. But I put the summary there for you. Okay? Now, what's the next checklist? Somebody else give me another checklist. So that's one thing you have to know. You have to know the scientific method. And what does it say? You have to memorize them? What is the word? What's the verb? And that first checkbox. What does it say? What about the scientific method? Identify. So you have to be able to identify. So what does that mean to identify? If you see it, do you know what the hypothesis looks like? If you see it, can you point to and say that's the question, that's the hypothesis, that's the experiment, right? So you have to know what they are, be able to identify. All right. What's the next checkbox? All right, I want someone from that back table that's so quiet. I'll start pointing fingers. You try to answer, so you don't have to worry about it. The rest of you three. And the next question is identify the hypothesis. So you have to. So I specifically want you to identify in a paragraph what the hypothesis is. You had to do that for your activity, didn't you? Correct? Why are you staring into space? Did you not do it? I'd like you guys to participate. I would like you guys, I'm going to go ahead and insist that you actually respond to my question. Is that fair? I'm the teacher. I'm asking you a question. I want you to answer. I want you to raise your hands or say yes or no. Say no. I don't understand what you're saying. I need you to reply. Is that clear? Sitting there quietly at 8 in the morning while I'm the one doing all the talking is not acceptable. We did this data nugget. Did we not? Yes or no? No. You didn't do it this data nugget? No, we didn't go over it, but you did it. You did it. We haven't gone over it, but you did it, correct? Yeah. I know we haven't gone over it. We're going to go over it this week. But in this data nugget, one of the first things you had to do was what? What is the hypothesis? So you can expect on the quiz you're going to get something like this, some kind of scenario. This is called a scenario, situation. And I'm going to ask you what? Which of these is the hypothesis? A, B, C, or D? Do you think it's going to be easy? It's going to be, they're all 4 answers are going to be very close. So you're going to have to be very careful. You have to read. You have to think. I'm going to make sure you think. It's not going to be hard. I'm not trying to make it hard. I'm trying to make you think. I'm trying to make you show me that you actually understand it. All right, it's not going to be the same situation. And honestly, it won't be as complicated because you only have, it's a quiz. It's not, I don't have time, it's not a project. But you will need to be able to identify an hypothesis. And we went over that yesterday, didn't we? What the parts of a hypothesis were? Okay. What's the next checkpoint? But thank you for answering what you answered. So you participated. No, but you answered no. We didn't cover that nugget. And that's participation. I appreciate that. What's the next bullet point? The parts of an experiment. Very good. What are the parts of an experiment? The outline. Remember in the pages 8, I think it was 8 to 10, they asked you to outline the experiment. What did they want you to do in the outline? Do you want to just do that now? Because we did it yesterday a little bit. Do you want to do that now? This is a question. Do this or do this. Say yes or say no. Don't just stare in there, stare into space. Come on, participate, people. He's not the only one. 90% of the class is sitting there like, I'm just going to sit here and be quiet, not cause any trouble, and then I'll just sit here and just be, shh. He won't notice me, he won't notice me, he won't notice me. I do notice you. You're my job. Is that clear? You are my job. I am here to teach you, not to teach a class. I'm here to teach you as a person. So I need you to participate. Does that make sense? That's what I need from you. I need you to participate. It's okay that you don't know. I'm glad you don't know because that makes me, that pays my bills. The fact that you don't know. If you knew it already, you wouldn't need me. I'd be out of a job. So you need to tell me you don't know so I can explain it. Oh, my explanation didn't work. Guess what? Ask me to redo it. Say, I don't get it. Okay, let me think of another example. Let me think of something else we can do. Let me think of something. I'll go ask another teacher, figure out what I can do. Whatever works, okay? But you've got to communicate. All right. Go on and let's go to this. Let's go to that second checkpoint and let's outline an experiment. If I'm going to do an experiment, what is the first thing I have to do? What checkpoint? I think we're on the third checkpoint, right? The parts of an experiment, huh? We're going to test. That's right. That's right. So let me write that. It's good to have a goal, right? Our experiment has to test the hypothesis. So if I give you an experiment that has nothing to do with the hypothesis, is that going to be a choice you're going to make? No, that's not an appropriate choice. If I give you 4 outlines and one of them is experimenting on something completely different, you can cancel that one out as one of your choices. So it has to test the hypothesis. And I give you examples in the summary. I give you an example and I walk you through it, by the way. If you read the summary, the things I wrote, I actually walk you through all the parts of an experiment in that summary. So you're testing the hypothesis. So the first thing you got to do if you're going to test the hypothesis is control all the variables except the variable that you're interested in seeing how it reacts. To the condition you set up. So when you're looking at a hypothesis, I'm just going to write an example here. If the plant does, or let me rephrase it. If the plant, bless you, gets more sun, then the plant will grow faster. So you're going to control everything except the one thing that you're not going to be able to control, because you're going to see how it changes, and what you want to see is how fast the plants grow. So that's the only variable you're not going to be carefully making sure is consistent. And you're also going to change what? What's the other thing you're going to change? The plant will grow faster or slower depending on the thing you change. What is the thing you're changing in this experiment, in this hypothesis? The sunlight. So how much sun it gets is what you're controlling, and whether it grows faster or not will change depending on the sunlight, right? So because of that, everything else though, how much fertilizer, how much water, the type of soil, where in the room, the humidity of the air, whether you sing to it or not, all that is going to be constant. It's going to be controlled. Does that make sense? Does that make sense to everybody? Okay, so notice that in this experimental step, controlling all the variables, is associated with this hypothesis. If here I'm telling you I control every other variable except for water, how much water I add, am I testing this hypothesis? If I tell you I'm controlling every variable except water, I'm going to change how much water, is that testing this hypothesis? No, it's not. It has nothing to do with this hypothesis. So that would not be a good choice. 2, you only change one variable at a time. And because you change it, what do we call this variable? Excellent. The independent variable. I think that leads us to the second part, doesn't it? What's another checklist? Is that one of the checklist points? Let me look it up. You're supposed to check off what you know. So if you don't know it, don't check it off. But so far we said, can you identify the different steps of the scientific method? We just defined them again here in class, and we've done it throughout the entire week. Given the experiment, can you identify hypothesis? You did it in the data nugget. We're going to go over it again here as I give you the answers to the data nugget. And we just went through what a hypothesis is, right? It's going to be tested, a testable statement. I gave you an example here on the screen, and there's also an example in the summary that you can read on your own. Do you know what the parts of an experiment are? Well, we're going through them now. First, that the experiment is testing the hypothesis, so you have to reflect that in your experiment. Second, you're controlling all the variables. That's a part of the experiment. You have to control everything except one thing. You're only changing that one thing. And that one thing that you change is called the independent variable. All right, so we're going to go through the rest of those steps in a second, but I also want you to look at the experiment part down here where it says experiment gets its own little section. Given an experiment, can you identify the control group? Well, the control group is something else you need. And you also have to, ask you the second bullet point under experiment says, given an experiment, can you identify the dependent, independent variables? So the independent variable in this example that we just wrote, i.e., for example, i.e. means for example, in this hypothesis, which is the independent variable? Which is the independent variable? The sun. So independent variable equals sunlight. And what is the dependent variable? That's right, somebody said it. That's right, plant growth. How much does a plant grow in a given amount of time? So there's your dependent, independent variable. Okay. Now, so that takes care of those. Do you know, all right, so do you know what axes these two go on? If I drew an axis, a graph. She says the dependent on the x and the independent on the y. It's flipped. That's right. So it's a good try. This is why don't feel bad about getting it wrong right here and now. This is where you want to get it wrong because I'm here to help you. We're here to help each other. We're a team in this. This is a space where you have to feel safe to be able to be wrong here because on the quiz on Friday, it's going to cost you points. This costs you nothing. It costs you nothing to be wrong right now. And in fact, it helps you. So the independent is on the x. I don't even know what I'm writing. And the dependent is on. So what would that look like in this example for this hypothesis? What would it look like? What's on the x? I don't know why I'm not hearing answers in hours. And what's on the y? Say what? Plant growth. Plant growth. Good. Plant growth. Let's say in centimeters per day. All right? And you're going to plot it. And then you'll put your best fit line. All right. So that takes care of that. Everybody get that so far? We're okay with that? No questions, no concerns? Ask you anything up to now, you're going to get an A. You're going to get the question right on the test, right? Because you got it on the quiz. All right, so that takes care of the variables that you keep the same, because you keep everything else the same except for the independent variable, and then you measure the dependent variable changes, and you put in a graph or a table. So that's the other part of the experiment. You're going to record the data. And then you're also going to analyze the data. Record usually means in a table if it's numbers, correct? Right? Yes, columns and rows. Analyze means you're graphing it. Right? Analyze means you're calculating a mean. That's an average. A mode, you remember that? Mean, mode. And what else? What's the other one? Mean, mode, and median. Mm-hmm. And someone else said range, and that's correct. So now you have some idea of what the data looks like, so you can make some statements, and then finally you come up with a conclusion. And that's it. That's what we do. That's an experiment. That's an outline of an experiment. Had you done that for the examples in pages 8, 9, and 10, And as long as you can identify that you're going to control all these other variables, the only one you're going to change is this, then you're going to be fine. And you would get 100% on. If it was an essay test, it's not on Friday. It's all multiple choice. But if it were an essay test, I would ask you to design an experiment. Go ahead. And I might ask that for extra credit because I figure most of you are going to get it done early. Some of you might need some extra time. So I'll just give you an extra credit question. And I'll ask you to design an experiment and outline an experiment. And that would be the kind of thing you'd have to outline. Do you think you can do that for extra credit? Okay. Now we're doing all this because I expect that you guys are going to do labs. And I'm going to want you to graph your data. I'm going to actually want you to be very careful in your measurements. I'm going to expect you to do this with an actual experiment. So we're not just doing this on paper. Is that understood? And also on the OST, they're going to expect you to memorize this and know this. Okay, so there's a missing part of this experiment. There's a really important missing part. In fact, this is not a scientific experiment yet. What's missing that's making it not a scientific experiment? What is missing that makes it not a scientific experiment? Well, you got the hypothesis, so that's good. I'm glad you said that. The hypothesis is right here, right? But what's missing? So you said test hypothesis. We had the, right, that's right. So I should say, let me start with, we already said that we wrote a question, right? We said it, I didn't write it down, but we did say it. We came up with a hypothesis. In fact, there it is, right? Here's your hypothesis. Then we went to the experimental phase where we tested the hypothesis, and these were all the things we did to test the hypothesis. So now the question is, what's missing in this experiment that makes it not a science experiment? Something's missing, something essential. Yeah, but we did mention research. So something else that's missing. These are all right. I didn't write them down. You're correct, but we did mention, but something we didn't mention or write down yet. It's in the checklist. It's in the checklist. It's that important. I said, let me make sure they. Okay, explain it is good. But something else? The control group. And I explained what the control group is in a summary. We did it in class. But let me be clear. I'm going to say it here. I'm going to write it here so that we're all on the same page. The control group is the group that you compare all the experimental groups to. All right, I'm going to give you some examples, all right, because I know it's hard to think of it when you look at things like this, but I'm going to give you some examples. Let me know when I can go on. Are we good? No. No? Okay, give me I'll take a sip of coffee. Are you ready? Okay. Are you ready? All right. So the control group, let me give you some examples. In this example, he said if the plant goes into sunlight, so we're probably going to put a plant, we're going to try to grow, we're going to try to grow a plant in 1 hour, another plant, and 2 hours, another plant, and 3 hours, 4 hours, right? You have a bunch of plants. So all these are going to be experimental groups. These are all going to be experimental groups. Where this is 1 hour, this is 2 hours, this is 3 hours, this is 4 hours, this is 5 hours, this is 6 hours, this is 7 hours, this is 8 hours, etc. What are we going to compare these to? The one on the far left is correct. So we're going to compare to this one. This is going to be your control group. What do you think we're going to do with this control group? See what? No sun. Correct. Put in the dark. 24/7. It's in the dark 24/7, no light. So if it grows without any light, there's a problem, right? Probably not a plant, but there's a problem. So I need to figure that out. You might even have another control group that's what? If it's we have one in all dark, what might we want? Another one that's in what? All light. And 100% light 24/7. And then all the rest we change. This would be called your positive control. And this your negative control, but you don't need to really. You just need to know it's your control group, the one that you're going to compare it to, okay? But some of you might want to know why we're doing two, because you want to know if it doesn't grow into positive control, you have a problem. If it grows into negative control, then you have a problem. Something's going on. You don't know what it is, but it's weird, so you have to figure that out. But other than that, every time it grows, you're going to compare to how well did it grow in these two, how well did it grow in these two, how well did it grow all the way across. So let's do another example. Let's do another really quick example. I want to find out if an antibiotic kills a bacteria. In fact, I want to know at what concentration. I haven't talked about concentration yet, but how strong? How strong does the medicine have to be to kill the bacteria? So I'm going to put it on a petri dish, and to this petri dish, I'm going to add, obviously, bacteria. And then some, let's say, I'm going to do this. I'm just going to repeat this like 4 times here, just to make a point. I don't think I need to do any more than that. So here I might try, 1 microgram per milliliter. You don't need to know what that means. This one's 2 micrograms per milliliter. This is 3 micrograms per milliliter. And this is 4 micrograms per milliliter. Okay, everybody get that? This gets stronger. I'm putting more and more antibiotic into the bacterial plate. You're okay with that? Well, what's going to be my control group then? What am I going to do to my control group? No micrograms, exactly. Perfect. That's right. 0 micrograms per milliliter. And I'm going to compare it. Because if they don't grow here, then maybe something's wrong with where I'm growing it, right? Maybe it's not the antibiotic at all. Maybe the differences doesn't have nothing to do. But in having this control group, I have something to compare it to. Does that make sense? So that's what a control group is. It's a group that you design the experiment around to compare your experimental groups to, so you can say, yeah, for sure, the antibiotic kills the bacteria, 100% of the bacteria at 3 micrograms per milliliter, and no, it wasn't anything else that killed it because I put everything else the same, except I didn't add any antibiotic, and the bacteria lived, but I added 3 micrograms per milliliter and the bacteria died. For sure, at 3 micrograms per milliliter, this antibiotic kills the bacteria. So I'm good. But I have to have that control group. If I don't have that control group, then the experiment's no good because I can't tell you that it's the antibiotic that's killing the bacteria if I don't have the control group. Would it help if I give you a human being version? Like a situation where you, well, no, I don't want. I was thinking about using the Tuskegee experiments, but I don't like using those for anything other than bioethics and saying how horrible it was that people actually did that. So tomorrow, we're going to go through the data nugget. I think we covered most of these checkpoints. We still got the accuracy precision 3, and we'll talk about that tomorrow. All right? It's not time to leave yet, but you can pack up. I'm going to take attendance. All right. Yeah. Is there anyone here who has problems with their grades at all? Any assignments that you turned in that are not being graded and not in Schoology? Is there anybody need any help with that? If you do, come see me now before you leave. Oh yeah. I Jupiter graded message. I sent you a Jupiter grade message. Let you know tomorrow in class you do have a retake of your syllabus quiz if you want it, or a makeup quiz if you didn't take it. So remember, pages 1 and 3. Know those dates and rules. Read your Jupiter messages. I think I sent that. Didn't I send it to everybody? Yes. Okay. Sometimes I don't send it. I mean to. Bennett. Here. Alka. Bolden. Absent. Brown. Chapman. Chapman, you here? Thank you. Dublin. Serenity, I'd like you to stay. Drake. Dunlap. Foster. Simtree. Gathright. Green. Henry. Johnson. Maggie. Frank. Pritchett. Stewart. Whitner. And Whitsett. What's up? Serenity, I want to see you. All right, I wish you would have came in a couple minutes earlier. See me right before you go to lunch. Serenity, sit up in front of me. What's up?
Do you want a copy of the syllabus? Because this missing.
It's the newsletter. If there's no newsletter there, I'll have to print one for you. Come and see me later today.
Wait, so do I have a session or no?
No, I just a warning to you. Please get a pass before you come late. Nobody listens to me. So, how are you feeling about everything? Did this help?
That's something I did in, I said 9th grade. $8 this 9th grade year, 8th grade year.
I can't. Can you? I don't want to talk private business with other people.
I said I did this in my ninth grade.
What grade? Oh, eighth grade year. Yeah. So you are comfortable with this material?
I'm familiar with
And
scientific.
all right, and you kind of like you understand what's going to be on the quiz, and
Yeah.
and the notes are helping.
I can get in Jupiter.
But you can get in. You can't get a Jupiter at all. Well, you're not getting any of your emails.
No.
Can you come to me before lunch? Before you go to lunch, or after you're done eating? You want to come after you're done eating? You want to come before lunch? Do you eat lunch here? Then go here. Take this with you. Go eat lunch and come back after you're done eating. All right, that'll get you out of lunch. All right, thank you.
Hey, Mr. Mendoza.
Hey, what's up? Ooh, I love your. What's it, Mickey Mouse you got on your little on your cheek? Why don't you have Mickey Mouse on your cheek? I like Mickey Mouse.
I don't want to have Mickey Mouse on my face.
I don't like Mickey Mouse. I love your
Oh, thank you.
your
So, like, I kind of got stuck.
I got class. I keep mentioning this, but I think it's really good to have that coming up. Kind of.
Oh, thank you.
All right, go to class now. Go to class.
Okay. Have a good day.
Bye-bye.
Your English book like later. Yeah.
You have a handout, guys? Oh, you okay? Is everybody all right? He's okay?
We're fine, yeah.
Okay. So sorry that happened to you. Huh? Yeah, take the passenger. Hey guys, you need a green sheet? Now I think that covers everything. I'm going down the checklist, the stuff I covered on this video. I covered, can you identify the different steps to the scientific method? We identified the steps. Given an experiment, can you identify the hypothesis? We talked about what a hypothesis has to look like. It has to be a testable guess, a testable prediction. If-then statement is what we try to teach you so that you get in your head. That has to be testable. Do you know what the parts of an experiment are? We talked about controlling all the variables except one. We talked about the control group. We talked about the experimental groups. We talked about the independent variable, the dependent variable. Given an experiment, can you identify the control group?
Yes.
Given the experiment, can you identify the dependent, independent variables? I hope so. Do you need to know what? Do you know what the axes of a graph, the variables are graphed on? I think we're yes on all those so far. Now, just because you know it now doesn't mean you're going to know it on Friday. Let's be clear, and I'm recording this for a reason. Because I'm going to play it back to you when you tell me I didn't remember. I'm telling you, just because you know it now does not mean you'll know it on Friday. That's where practice comes in. If you're not reviewing this, if you're not quizzing each other, if you're not looking at the examples, and we're going to go through this rest of this data nugget to make sure that we go through a good example. If you're not practicing this, guys, you're not going to be, you may or may not get it right on the quiz. If you do all that, you might find the quiz is extremely easy. But don't come out of Friday saying, oh, that quiz was easy, I don't need to study. No, say, that quiz was easy, I did right. I must have did my studying correctly. Because if you study correctly, all tests are easy. There is no hard test if you prepare for it. Well, for the most part, anyways. Why are people putting stuff away? Okay, just asking. If I give you accuracy and precision, if I give you a set of data, can you identify which is more accurate? Why are people putting stuff away? My buzzer didn't go off. No one should be putting stuff away and standing up. Book bags are out. What is going on? No, that's a no-go. No, that's you, no-go. You are wrong. Wrong. I think I'm going to have to split that group up in the back. Well, I'm going to have to split up the group. I didn't say how I was going to split them up. All right. So if I give you a set of data, and maybe it looks like this. Maybe I might ask you which one is, or it might be a table. It might be a table with data, and you know, it might say we know that the actual number is our theoretical. The number that we predict number is this, I don't know, 5. And you get a bunch of and I give you a bunch of numbers here. 1, 3, 5, 5, 5, whatever. Can you identify which set of data is more accurate? Can you identify, if I give you 2 sets of data, if I give you one list of numbers that looks like this, and another set of data, and I'm just sketching this out, another set of data that looks like that, can you tell me which one's more accurate? Yeah. The first one, A, correct? And A is more accurate. Which one's more precise? B. You get the same number every time. Why? So the last question is a little bit harder. The last bullet point there is a little bit harder. Why might a scientist prefer to be precise if they had a choice between accurate and precise? Why might they want to be? Obviously, our goal is to be both. But if you had to pick one, why might you prefer to be precise and not accurate? Not necessarily as accurate, at least the first time you do it. Yeah?
Because you know it's repeatable.
Yeah, you know it's repeatable. And then you can find out what you're making a mistake on, and you can adjust. Does that make sense? So having high precision allows for adjustments that are predictable. Now, last week or the week before even, I can't remember, I gave you the example of me winning a teddy bear every time my wife and I go to Cedar Point by shooting. You remember that? The whole idea that they purposely make that device not accurate, but it's going to be precise because I control everything else. So as soon as I get precision, I can make an adjustment and hit the target. So what you do is you want high precision first, and then you can adjust for accuracy. So when we're looking at science, precision is sometimes more valuable than accuracy because of that. All right, I'm going to take attendance so you can wrap up, and don't leave till I call your name.